Hi everyone, it's Mr. Allen. We're going to go over our first option, option A here, for solving exponential equations. The questions we see today will be sort of the easiest ones to solve. The form you can sort of see looks pretty much the same in each question. Obviously there's going to be a little trick to each one, and we'll sort of go through them super quickly here. Now the first case, I'll just pull this right down, I guess. In the first case, if you see something that looks like this, 2 to an exponent equals 2 to the same exponent, or sorry, 2 to another exponent, the same base in this case, should be fairly obvious that what the equal sign is telling us is that this is exactly the same as this, which means that since the bases are the same, the exponents must be equal as well. And then it's pretty easy to kind of determine that if these two things are identical, then this must be equal to this, and obviously x equals 4. Divide both sides by 6 here, we get that x equals 4. Okay, so that's kind of the first thing to look for. If you do have that much information where the bases are already identical and two things are otherwise equal, pretty straightforward stuff. This exponent will be equal to this exponent, and then once you state that, you can solve using regular Bedmas type rules. Add 1 to both sides in this case and continue on. Now as far as just the steps required, or the steps required to be shown, let's say, if you don't write this step in, that's fine. Just like I actually didn't write in the step here that I intended to, which was 6x divided by 6 equals 24 divided by 6. If you don't write those steps in, that's fine, as long as you know what you're doing, of course. And then as we move forward, we can sort of see that we have the same base here, 36 and 36. We have to remember what the square root means in terms of exponents, though. A square root is the same as exponent 1/2, and so this is essentially 36 to the exponent x, all to the exponent 1/2. From last day, x times 1/2, when we have an exponent to an exponent, that's a power rule, and so x times 1/2 is just x halves, if you will. And now these two exponents again will be equal because the bases are equal and the entire equation is equal, and so this will equal this, and solve it however you need to. Subtract the 1/2 x over, subtract the 2 back to the subtract the 2 from both sides, it ends up -2 over here, and then simplify. I will try very hard this year not to use bad math talk, saying things like move the 2 over here. Sometimes it still slips out, but of course what's important here is to understand you know that what you're doing is you're subtracting 2 here, and to keep the two sides of the equation equal, you're subtracting the 2 over here. 2 minus 2 is 0 here, and I am left with -2 on this side. Okay. Now those ones are all fairly obvious. Those are kind of added in just to sort of make the point of where we want to get with the tougher questions. Certainly the majority, if not all the questions you see, will look closer to these examples than the first two, but the point still remains the same. If I have the same base on one side of the equation as on the other, then my exponents will be equal as well. And so if I have something that looks like this, what I'm really asked to do is rewrite this write this term in terms of that same base. 64 is to the exponent 6, and so now if these two sides are equal, which of course we've established by writing this down, 6x must be equal to 6, so x is 1. Same sort of thing over here. If I can rewrite this with a base of 3, and we want to remember this, I guess we could have rewritten first as that. From our exponent rules from last day, the -1 tends to flip our base, so if we want to flip it back over, we can bring it back to what it was, which is 243 to the -1, and then by trial and error we can figure out that 3 times 3 times 3 times 3 times 3 is 243, and so that's 3 to the exponent -5, and now again same as before, this exponent equals this exponent, and solve. And then last one, this is just a combination of kind of a few of the ones we've seen. Again, this is essentially 1296 to the exponent x to the exponent 1/2, 1296 to the exponent x halves, and then write this as a base of, oh yeah, sorry, I got a little bit ahead of myself here. We're trying to write these two things with the same base. Of course, in this case, 36 is a little bit of an odd base. I guess I actually would have worked, so it's 36 times 36, isn't it? So I could have left this as 36. Sorry, now I'm babbling a bit. And written this as 36 to the exponent 2. But my first instinct was to jump to base 6. So 36 is the same as 6 squared. 4x plus 2 is the exponent that was there. This is 6 to the exponent 4. X halves is the exponent that was there. And now this whole exponent will be equal to this whole exponent. And so multiplying it through, 8x plus 4 equals 4x over 2, which is 2x. And did I actually mess that up? No, I guess I just skipped a step here. And so therefore, I'll write this into your handout before I send it. We've got 8x plus 4 equal to 2x, and then subtract the 8 from both sides, 8x from both sides. I get 2x minus 8x is negative 6x, and simplify further. Okay, so just sort of a step that was a little bit skipped in here. As I said, I'll write that into the other one. But again, first key, anytime you see these types of exponents, we're looking to establish, can I write both bases, or can I write both expressions in terms of the same base? And if I can, then it's just a matter of making the two exponents equal and solving.